Welcome back, print production pros, to this explainer. Listen, today we are delivering a high-signal, strictly zero-fluff breakdown of your production floor. Our core objective here is simple, but honestly, it's absolutely critical. We're going to completely dismantle the widespread myth that direct-to-film consumables are just these interchangeable commodities. Seriously, if you've been treating your shop's supplies like they're all exactly the same, well, you're definitely going to want to pay close attention to the science we're about to unpack.
Let's start things off by asking a really common operational question. One that, let's be real, causes endless headaches in print shops everywhere. Where do substrate failures actually start? You know, when a print goes wrong, it's almost a reflex for operators to just instantly blame the heat press. But the reality of the situation? It's rarely where operators think it is.
Because the absolute truth is this: substrate failures do not start at the heat press, not even close. They actually start way before that, with mismatched consumables. Treating your inks, your films, and your adhesive powders interchangeably doesn't actually save you money. In fact, it actively destroys your shop's margins. In DTF production, you aren't just putting ink on a page. You're dealing with a highly complex chemical relationship.
Okay, let's dive straight into our roadmap for today. We're going to cover the consumable commodity myth, then look at engineered film release coatings, move into surface tension and chemistry, examine the adhesive powder bond, and finally, wrap it up with the closed-loop system.
All right, Section 1, the consumable commodity myth. And spoiler alert, they are not interchangeable.
Treating inks, films, and adhesive powders as interchangeable commodities is the fastest way to destroy your margins. I mean, that really hits the nail on the head, right? This isn't just some vague warning. It's a cold, hard operational reality. And we're about to prove this to you using strict chemical science. See, when you just mix and match these components based purely on what's cheapest that week, you're introducing massive, unpredictable variability into a process that quite literally demands absolute precision.
Moving down to the very bottom layer in Section 2, engineered film release coatings. We're talking about the microscopic layer here.
So the really crucial point you have to understand is that DTF film is not just a basic sheet of raw PET plastic. It actually features a highly engineered microscopic release coating. And this tiny environment has two incredibly critical jobs. First, it has to grab and hold the wet ink exactly where it lands to prevent it from pooling up. And second, it has to release that entire cured design completely cleanly when it's peeled. It basically has to grip the ink, but, not too tightly.
This is a perfect illustration of the exact chemical balance required. Think of it like a tightrope walk. If your film coating is too aggressive, the cured ink simply won't release. It just stays stubbornly stuck to the film. But on the flip side, if that coating is too weak, the wet ink is going to migrate right across the surface, completely blurring your edges and ruining all the fine details of your design. Finding that exact chemical balance is literally the difference between a flawless transfer and a pile of ruined shirts on the shop floor.
Let's step one layer up the stack to Section 3, surface tension and chemistry. This is all about chemical alignment.
Before we go further, we need to clearly define surface tension. In this specific context, it's the precise chemical formulation of a DTF ink set that dictates exactly how it's going to interact with that film coating we just talked about. Every single DTF ink set out there is formulated with a highly specific surface tension. So when you just arbitrarily mix ink brands, you are creating total chemical chaos because you're throwing off this incredibly delicate mathematical and chemical alignment.
Now, what's really fascinating here is what happens when these ink layers actually meet. When your ink chemistry aligns perfectly with the film's coating, when they're properly matched, your 𝗃𝗃 layer sits completely flat, and that allows the white underbase to sit perfectly right on top of it with zero bleeding. But when they're mismatched, the white ink will actually repel or just completely mix in with the 𝗃𝗃 layer. The result? You get these gross, muddy colors and a total loss of your fine detail.
All right, that brings us right to the top layer for Section 4, the adhesive powder bond, or the hot melt phase.
110 to 120 degrees Celsius. For those of us using Fahrenheit, that's roughly 230 to 248 degrees. Let me emphasize this. This specific, tiny temperature window is exactly where the final piece of the compatibility puzzle has to happen. The polyurethane powder absolutely must melt and bond perfectly with the wet white ink layer right at these exact temperatures. If the chemistry underneath it is wrong, that bond is going to fail entirely.
To really understand why that powder bond fails, we have to look at a specific chemical additive called a humectant.
So a humectant is put in there specifically to keep the ink wet inside your print head so it doesn't clog. And obviously, it is completely necessary for your hardware to function. However, if this chemical gets unbalanced because you're mixing up your consumable stack, well, it suddenly becomes the ultimate enemy of the powder bond. And here is the grim reality for your bottom line. It really boils down to this simple equation. If your mismatched ink contains too much humectant, it literally blocks the powder from bonding properly to the white ink. And what happens next? Boom! You get the absolute worst customer complaint possible. The print just starts peeling right off the garment after the very first time they wash it. The print probably looked perfectly fine leaving your shop, but because the underlying chemistry was compromised, the product was doomed from the start.
Zooming back out to the big picture, here's Section 5, the closed-loop system. Let's talk about actually solving compatibility.
So here is the compatibility puzzle completely solved. Step 1, coated film. Step 2, matched ink. Step 3, polyurethane powder. That's the whole shebang. Locking in these 3 synchronized layers as a single engineered system completely eliminates the guesswork on your shop floor. It ensures that your release coating, your ink surface tension, and the powder's bonding requirements are literally all speaking the exact same chemical language.
So, at the end of the day, why does all of this matter? Well, the operational payoff is honestly massive. When you strictly match your ink, film, and powder, you are going to see significantly reduced variability. You get radically simplified execution on the floor, mostly because your operators aren't having to constantly tweak machine settings just to compensate for random chemical mismatches. This directly prevents costly reprints and ensures drastically improved consistency across every single batch you run. Predictable systems save you time, and for sure, they save you money.
I want to leave you with one final, absolutely crucial question to ask yourselves as you audit your own shop floor supplies today. Think about this. Are you treating your consumable stack like an exact science? Or are you literally just guessing? Remember, in DTF production, high margins require high predictability. So stop treating your consumables like cheap commodities, respect the chemistry of the process, and watch your operational consistency completely soar. Thank you so much for joining me for this explainer. Keep learning and keep optimizing out there.